On Friday, we did y equals and we put this in. So tell me, what are all the factors of 48? Ready, go. Yeah, that's not you. Other side. 48 people. What were the factors of 48? 1 and 48. Keep going. Okay. Perfect. All right. Factors of 64. Ready, go. So we don't do repeats. Okay. So the greatest common factor, 16. I'm not right now because it took so long for that to record, but thank you. All right. So now we're going to use the same idea and we're going to play a game. Okay. So I'm thinking of two numbers that I can multiply together that equal 6, but when I add them, they're 5. So in your calculator, if you did y equals 6 over x, you could list all the factors of 6. Hopefully this is a really easy number, and we know that 2 times 3 equals 6, and 2 plus 3 is 5. So the numbers that we're talking about are 2 and 3, sir. Yeah, I was writing it up there. That one was hopefully pretty easy. So what about number 2? I'm thinking of two numbers that multiply to -6 and add up to -1. -3 times 2 is -6, and -3 plus 2 is -1. So the numbers are -3 and 2. I agree. Okay. I'm thinking of, we're just going to keep doing this until you guys get the gist. I'm thinking of two numbers that multiply to 20 that add up to -9.
-4
and I called on Kane. I'm so sorry. I pointed at him because I had a mouthful of food. I mean, not food, drink. Go ahead. Yeah, -4, -5. Trevor, you can have the next one. I apologize. -4 and -5 equal +20. -4 plus -5 equal -9. So some of you guys aren't writing this down and you're napping, and I'll just tell you that what's going to happen is eventually we're going to have an activity where you're going to have to do this without me coaching you, and you're going to be like, I don't know how to do this. And I'll say, look at your notes. And then you're going to get frustrated with me because your notes aren't filled out. So pay attention. Number 4, Trevor, thinking of two numbers that multiply to -12. And when I add them, I get +4.
-6 times 2 and -6 times 2 and then -6 plus 2.
So -6 plus 2 gives me -4. So what do I have to do? Change the order of the negative, right? How about if I do +6 and -2? So here's a perfect example. I couldn't have done this better if I'd planned it, Trevor. Nice job. Here's a perfect example of when you have the right factors, but you just have the negative on the wrong term. So 6 plus -2 equals +4. So my numbers are 6 and -2. All right, Kate, I'm thinking of two numbers that when I multiply them together, I get -49. And when I add them, I get 0. You're fine. Kate's working on it. Thank you.
+7, -7.
+7 and -7 equal -49. And +7 plus a -7 equals 0. I agree. Okay. I don't know why, but those are some of the hardest ones to see. Thinking of two numbers that multiply to 64 and add up to -20. Yeah, -16 times -4 is a +64, and -16 plus -4 equals -20. Okay. I'm thinking of two numbers that multiply to -84 and add up to -5. Kane, I'm going to call in someone else, okay? I know you get it. I know you get it. Multiply to negative 84. Abby, two numbers that multiply to negative 84, that when I add them, I get a negative 5. So look at factors of 84. One's got to be positive, one's got to be negative. Say that again. So negative 1 times a positive 84 equals negative 84. But when I add those together, Abby, do I get negative 5? No. So what are some of the other factors on your table? Factors of 84. Do you see what I'm asking you for? So let's look at these. So factors of 84, let's see. 4 and 21, there's no way the difference of that is 5. 6 and 14, let's see. If one is positive and one is negative, 14 minus 6 is 8. I'm getting closer. What about that one? One's got to be positive, one's got to be negative. So negative 7 times 12 does in fact equal negative 84. But when I add negative 7 and positive 12, I get a positive 5. And I need a negative 5. So what does that mean I need to do? Switch the negative. Let's make the 12 negative. So negative 12 and positive 7 equal 84. And negative 12 plus 7 equal negative 5. Do you guys see how that works? So my numbers are negative 12 and positive 7. I don't know why I wrote 5. Negative 12 and positive 7. Okay. All right. Next. Logan, can I call on you? You ready? Use your calculator. Two numbers that you can multiply together to get one. It's negative 114, but just put the positive number in your calculator. 114. And it adds up to 13. So you're putting 114 in your calculator, right? So we're looking for the product. You're doing y equals 114 divided by x. That's what you're doing. And then I want you to go to your table, second graph. Do you want me to come look? So we're looking for a difference because this is a negative number. We're looking for a difference of what? A difference of 13. A difference of 13. So what are my two numbers that I'm using? I'm using 6 and 19. Do you see that? Yes or no? Do you see that I just scrolled down to the 619 on your chart? Okay. So that table says that 6 times 19 equals 114. That's why we're using a calculator to figure this out. Okay. What I know is that since I'm looking for negative 114, one of those numbers has to be negative. If I make the 19 negative and I take 6 plus a negative 19, I end up with a negative 13. But I want my sum to be a positive 13. Do you see that? So that means that I have to make the 6 negative. Negative 6 times a positive 19. It still equals the negative 114. But when I add them, I get the positive 13 that I'm looking for. So the numbers that I'm looking for are negative 6 and positive 19. So those of you that aren't using your calculator like I've asked and you don't really understand what's going on, this is not going to help you. Okay? All right, Eli, you're up next. So let's go figure out what numbers can you multiply together. Don't help him. Let him do it on his own. 153. So y equals 153 divided by x. I want everyone to put that into their calculator. Y equals, I'm coming, 153 divided by x. I'll get it in a second. I'll give you my notes. We're going to do y equals 153 divided by x. Okay, so go to your table. Let's pick out factors. Y equals 153 divided by x. So, Eli, what are some factors? What are some factors of 153? We want it's a positive 153, but their sum is negative. So that means probably both of them need to be negative terms. Okay. So what are some numbers that I can multiply together to get 153? Just list some of their factors. 9 and 17. Let's see. If I had a negative 9 times a negative 17, that's going to give me my positive 153. And negative 9 plus a negative 17 equals a negative 26. That will work. Numbers are negative 9, negative 17. I purposefully picked numbers that you don't see a lot, like multiples of 17 or 19 or 13, because those are hard to think about because they're prime numbers, right? So I'm trying to twist your brain a little bit. All right, tier. Thinking of two numbers that multiply to give me a negative 143. A negative 143 that when I add them, they equal 2. I don't think there are very many factors of 143. You can't find anything? Okay, stop. Stop. Let's look. So positive 11 and negative 13. That doesn't give me a positive 2, but what about 13 and negative 11? Does that add up to 2? So 13, negative 11. 13, negative 11. I want to tell you guys that I never use the negatives in my calculator, ever. So positive 13 times negative 11 equals negative 143. Positive 13 plus a negative 11 equals 2. So the numbers in question are 13 and negative 11. Last one, Naya. Two numbers that I can multiply together to get negative 81, that when I add them up, they equal 0. Awesome. Negative 9 times positive 9. Negative 9 plus 9 equals 0. So the numbers, negative 9 and positive 9. So let's just talk about some of the things that we've discovered. When I am looking for factors and the product is positive, so the product is a positive number, but the sum is a negative number, what have I discovered? If the product is positive, like example number 9, but the sum is negative, what does that tell me? That both my factors need to be what? Yeah, both factors are negative. Okay, this is just something that hopefully you discovered. What about if my product is positive and my sum is positive? All my factors are positive as well. Okay. What about if my product is negative? If the product is negative and the sum is positive, what did we learn? Yeah, the larger factor needs to be positive. So this idea of what we've just done, like you guys might not have written this out or thought about this, and you don't even have to necessarily put that in there, but I want you to think about what is really happening, right? What is really taking place? Because sometimes I'm going to give you a trinomial and it's going to be the same factors, 1 and 3, but they could sum to 4, they could sum to -2, they could sum, do you know what I'm saying? Like it just could be very different, right? So we have to figure out what's really taking place. So we're going to do this same thing, and I want to tell you like what the end result is. So we are working with trinomials. You guys worked with these last week and the week before. But how you worked with them is you started with a binomial times another binomial, right? And you foiled, do you guys remember that? When you foiled these two numbers, you ended up with this. So now we're going in the opposite direction. Last week you started with the two factors, we called them binomials, and you foiled to get the trinomial. This week we are starting with the trinomial, and we need to end up with factors, the two factors, two binomials, okay? So what does that mean? Well, that means that using this ax squared plus bx plus c, which is the standard form, we're going to fill out a times plus chart, right? So times plus, God bless you. So we are going to take a and multiply it by c. That's where this number right here is going to come from. That's why I wrote ac. That's a product, a times c. B is the middle term, B, okay? And we're going to play the same game. What two numbers can I multiply together to equal this, that when I add, I get this, okay? So same game, but it's solving a trinomial. So let's look. If I want to figure out the product right here, I have to take a times c. So the number attached to the x squared is a, so 1, times c is 14. So what is 1 times 14? Okay. So I want two numbers that multiply together to equal 14, that when I add them, I get a sum of, what is the number attached to the x term? Okay, hang on. That when I add them, I get a -9. You jumped the gun. You get a -9. And yes, the two numbers are -2 and -7. Okay. So let me tell you what that means. It says play the game like you did above. So we've kind of filled out our times plus chart, and I'm moving down to step number 3. It says plays the game like you did above to make your product and sum, and then place the numbers that you find in the second position of the parenthesis. So remember, these are binomials. X squared came from taking x times x. Does everybody see that? And then the two numbers that we chose are the numbers that we put up here, -2 and -7. Those are our factors, okay? Those become our factors. So we could check this by foiling it. We could check it by foiling it, but I don't want to foil it right now. Okay, let's do the next one. What's my product that I'm looking for? What's my product? What's my product? What? I have to take a times c. What does that give me? It's a -168. So a times c is -168. B, the number that they have to add up to is what? 2, a +2. So I would definitely use my calculator. I would find out all the factors of 168. Y equals 168 divided by x, because 168 isn't a number you see a lot. And I would go to my table. Wait, what? I said 168 divided by x. I don't ever use the negatives. I never use the negatives. What? 14 and -12. +14 times -12, because 14 plus a -12. Yeah, those will work. So I'm going to write it out. Remember that the x squared is made by taking x times x. And it says down here, the numbers that you find become the second position. So that's a +14. I need to make sure I put a plus there. And a -12, which becomes a minus. Okay. So I'm going to write something that I think is super duper important. So here's a special note. What has been the value of a in both of these examples? 1. So here's a note. When A equals 1. And all of the trinomials that we're going to solve this week, for the most part, probably until Friday, are going to have a leading coefficient of 1, okay? Because we're just going to keep practicing. So when A equals 1, the factors you choose are the factors you use. Notice that when A is 1, so here it was 1, the two factors that we get down at the bottom are the factors that we put in our binomials. They just are what they are. That's going to make your whole job so much easier right now. So we're just going to practice finding the factors and then writing the product of two binomials. That's all we're doing right now. So everybody should be writing down that special note, not just staring at the board. When A equals 1, the factors you choose are the factors you use. Oh my gosh, Riley left his calculator. So if you want to scroll down, I know a couple of people are still writing. If you scroll down right below that number 4, it's just asking you to put this in there. It's just wanting to know, hey, what did you get for your two factors of that first trinomial? And what did you get for your second? Because if you see, it's the same problem repeated. It's just asking you to write it out. So we said this was x minus 2 times x minus 7. And this one was x plus 14 times x minus 12. Does everyone have the factors you choose or the factors you use written down? Double note, girl? Yes? Aren't you doing Dakota's notes? Okay. All right. Here we go. So I just rewrote those, right? Because it's just saying, hey. So I'm going to check one of them. Which one do you want to check? The first one? Okay, so I'm going to do the box method because you like it. So I'm going to check and make sure that this truly, the product of these two terms equals this. So I'm going to do x and a negative 7, x and a negative 2. You don't have to write this if you don't want, but I want to show you that it does work. X times x is x squared. X times negative 7 is negative 7x. X times negative 2 is negative 2x. And negative 2 times negative 7 is a positive whopping 14. Remember that you can almost always group those terms on the diagonal. So that leaves me with x squared. Negative 2 and negative 7 become negative 9x plus 14. Looks to me like we did it properly, right? So checking by foiling or factoring is a good method, by foiling or using the factor box, but you don't have to, okay? Questions? Okay, you guys have number 1 and 2 at the bottom. I'm going to freeze the screen. You guys are doing number 1 and 2 at the bottom. It says now you try. You're doing number 1 and number 2. We're not even ready for that. Not even ready. Ma'am? On page 2, I missed one. You're awesome. Thank you. So you guys do number 1 and number 2. Compare with your friends. Make sure you get it right. So hopefully for number 1, it's a problem that we've already actually done. We did that in the, hey, I want to play a game with you. What two numbers can I multiply together to get a positive 20 that add to a negative 9? Negative 4, negative 5. So I should have x minus 4 times the quantity x minus 5. That's how number 1 factors. Number 2, x squared plus 10x plus 20. My times plus chart, a times c is 24. B is 10. What two numbers can I multiply together to get 24 that when I add them, I get 10? X plus 6 and x plus 4. Because both of those are positive, I have to make sure I put them in there with a plus. That's what that little note number 4 says. Watch your sign. If it's positive, join it with a plus. If it's negative, make sure you put a minus in there, okay? You just got to be careful about that. Okay. Questions? Okay, so I'm going to talk to you about your homework for today and your homework for tomorrow, because we're just going to operate under the same idea that maybe I'm not going to be finished yet and we're going to have to house you guys somewhere else. Okay. So for today, I'm just sliding up a little bit. So homework for today. Today is Tuesday, and this is all written in the module, but I just want to make sure we understand. So today you're going to do page 1 of your note packet. Page 1 of your note packet. You're going to do 1 through, sorry, I just already messed that up. 1 through 10 all. 1 through 10 all. I'm writing it down as soon as I get a marker. So 1 through 10 all. And you're going to do 12, 14, 16, 18, and 20. Okay, page 1 of your note packet, 1 through 10 all, and then 12, 14, 16, 18, and 20. Remember that you also need to finish, if you did not, you need to finish the EDIA, greatest common factor assignment from Friday. I think it's called factoring out a GCF or something like that. I can't remember. Okay. Hang on a second. I'm not done. Okay. So that's for today. Tomorrow, in case I don't see you, and again, this is in the module for tomorrow as well, but I just want to make sure that you understand. So for tomorrow, you are going to do page 4 of your note packet. And you're doing all of it. You have 90 minutes. I'm not teaching you a lesson. 16 questions. You'll be fine. You're doing all of that. All of that. And you also have, it's just like what we did. Okay. And you also have a Delta math called factoring trinomials. Factoring trinomials. Now, if we do get together tomorrow, once you guys finish that, I do have another activity because we're going to finish this note packet for sure this week, right? It's a short week, but we'll get through it. The Tuesday assignment is going to be due Thursday at the beginning of class. So this is, I'm going to put a little note that says due Thursday. That's going to be at the beginning of class because I'm just going to pretend that I don't see you tomorrow. Even if I do, Tuesday's assignment is not due till Thursday at the beginning of class. The Wednesday assignment is going to be due Thursday at the end of class. Does that make sense? I'm not really teaching a lesson on Thursday. Okay. All right. So I'm going to go to the module just so everybody can see really what's in there. I feel like I've kept it secret, but no, I really haven't. So it says video lesson. So here you go. Page 1, week 7.